Okay, we're going to go ahead and move on with our next presentation this afternoon. I know we're all ready to get out of here, so hopefully we can get through the next two pretty quickly and get you on your way a little bit early today. So this next presentation is thickness and tonnage control. In this presentation, we're going to talk about MAF factors, checking the mat thickness, as well as rate of speed, yield, a few of those items you all are familiar with being out in the field. So this is a typical cross-section, and Nathan, I think I'm like you, it's about time for me to ditch what's an old presentation that's been passed through several iterations and pull, some new graphics and things, because this was when we still had the sandwiched OGs, and so our cross-section doesn't look quite like this anymore, but the concepts are still similar that we're going to talk about today. For a typical cross-section, we assume a density of 110 pounds per square yard per inch for a regular mix. And so what we're going to talk about here is what happens if you use aggregates that are either heavier or lighter weight. We're talking about slags. Steel slag tends to be heavy. Blast furnace slag will make your mixes lighter. And how does that affect the distance that your asphalt that you place will cover? And what does INDOT do to compensate for that when it comes to your pay? All right, so an MAF is just what I just said. It's an adjustment to the lay rate and the pay quantity to maintain your design thickness for all of your varying asphalt material densities. So if you do have that MAF factor of 1.000, that is assuming you're within a range, okay? Stay within that. INDOT will allow you to continue to use that number. They give you a little flexibility with how that weight varies. And that's based on having that 110 pounds per square yard per inch. We don't use the MAF factor when it comes to open graded mixtures, temporary, any type of patching, widening mixes, anything that you typically associate as being a 402 mixture. Okay, so in the INDOT spec book, MAF references can be found in these sections. I'm not going to go through them, but you can find them if you go look at the INDOT spec book either online or if you use the printed out version that we're used to having, out in the field. Okay. So this is a good graphic that illustrates the difference between your various thicknesses for the different MAF factors. So most of the limestone gravel mixes that we have here in our state use the MAF of 1.000. The blast furnace slag tends to be the aggregates that we find in our mixes that do affect the MAF and lower that, whereas the steel slag, very heavy aggregate, will increase our MAF above the 1.000. So we're going to do a little math. This class used to have an exam, I think 5-6 years ago, so you'd have to go through and solve all these calculations. All of this is done for you on the DMF form. Some of this that you may hand calculate in the field, but most of it's going to be given to you, so we don't expect you to necessarily be able to do all of these calculations on your own, but understanding how they're figured may be helpful for you. So we're going to go through these fairly quickly. Feel free to pull out a calculator, jot down some notes in your notebook, or you can just kind of listen and follow along on the slides. So first off, to calculate your MAF, the formula for that is that you're going to take the specific gravity of your mixture. You're going to divide that by a given specific gravity that's found on a table. And this is based on the average from all of the limestone mixtures that we use. Once you have what that MAF factor is, you're going to look at the range, the specified ranges that INDOT gives you, and that's what tells you if there is going to be an impact to your specific mixture and on your specific project, or if you are within that range of the 0.98 to 1.020 where you won't be affected. And then here's just a quick slide showing what those MAF factors are, or how that calculation is figured from the given maximum specific gravity on the tables. You'll notice it's slightly different for a 9.5 millimeter surface than it is for all of your other mixture designations. And then this says, similar to what we've already repeated, if you're within that range, you do not adjust your MAF between 0.98 and 1.02. When you're outside of it, that's when the calculation comes into play. So that's when you adjust your MAF by taking your calculated minus 0.020 if you were greater than 1.020, and you add 0.020 to your MAF factor if your calculated is less than 0.98. So you're adding when you're using a blast furnace, you're subtracting when you're using steel slag. Okay, so hopefully that in a nutshell kind of covers what we're talking about here. We're going to do our first practice problem together. This is a surface category 3 mix. Your specific gravity that's given to you on your DMF is 2.463. Because you're using a surface mixture, you know that 2.500 is what you're pulling as your GMF from the table. And it's really just a simple division. 2.463 divided by 2.500 is 0.985. Okay, because 0.985 is within that range, the INDOT allows you to keep your MAF as the same. Your MAF for this mixture is 1.000. Are there any questions on that? Okay, same sort of problem here. You're given that it's a category 3 surface mixture again. Your specific gravity is a little bit higher for this mix. It's 2.360. So when you divide 2.360 by 2.465, you do get that you're lower than that lower limit of 0.980. 0.957 is what your number is that you get for your calculated MAF. And so then you're going to adjust your MAF by adding 0.020 to what you had calculated. And that's when you get an MAF for this mixture of 0.977. Any questions? Okay, like I said, the good news is it's given to you on the DMF form, so you're not going to need to calculate this on your own, but it is something to pay attention to if you either work in the lab or specify a mixture on your project. All right, so with that, it is time to apply MAF to our production rates. So MAF will impact what your late rate is. It's going to affect your planned pay quantity, and so it's important that you calculate that before you move forward with production so you understand what the impact of that will be. I guess just to kind of back up, in a nutshell, INDOT is wanting, they specify projects to be paved from point A to point B. And if your mixture you're using is heavier, you're going to have to use more of it, right? And because they pay you by tonnage, they like to be able to then say, well, we're going to pay you less per ton of mix because that mixture isn't going to go as far. And then the converse of that is true. If you're using a blast furnace slag, because they're paying you by ton, your mixture is actually going to go much further than what would have been specified. And so that's where you want to make sure that you understand what the impact will be to your pay quantity. These are the two formulas you're going to use for your adjusted lay rate as well as your planned pay quantity. Another quick practice problem here. If you are given that your lay rate's 165 pounds per square yard, you have an MAF factor of 0.970, and it gives you a planned quantity of 4675. What is going to be the adjusted lay rate as well as the adjusted planned quantity that you're going to need? So because MAF does come into play here, you're going to take 165 divided by 0.970. And that means your adjusted lay rate is that you're only going to be laying 160 pounds per square yard instead of 165. And then the adjusted planned quantity will be 4675 tons. You multiply that by 0.970. So your adjusted quantity is only 4534 tons. Again, because your MAF is less than 1, less mix is needed because that mix will go further by weight. Any questions on this? So we're going to move forward with applying our MAF to our final pay quantities. Your adjusted pay quantity is going to be your measured pay quantity divided by your MAF. So again, if your mix going further or maybe not going quite as far enough, INDOT adjust your pay accordingly. Practice problem number 4. Again, same measurements as before. They give you your planned lay rate and your MAF. For this one, your measured quantity is 4505 tons. So for this, you're wanting to calculate what is your adjusted pay quantity. Take 4,505 divided by 0.970, and that gives you 4,644 tons. So INDOT's actually paying you for more tons than what you laid because you're using a lighter weight mix. All right, so that's all I had on MAF. We're going to switch gears and talk very briefly about yield. So we all have seen these devices used out in the field. It's a quick check to see where you're at as far as your depth and expected depth that you should be paying, and seeing what kind of variability. We know that a lot of times our cross sections of our roadway look like what's down below, so it's not exactly the easiest and most reliable way to determine what your yield is. It is a good spot check, and I think it's important to know that, like with innovation equipment where they have all of the GPS and things built into that, it's making it maybe more consistent as far as what our cross sections look like, but it is still something you have to spot check as you go throughout your project. And it can be problematic if you don't stay on top of what your yield is throughout your shift. So for that, we're going to look at maybe a couple of other ways of calculating yield. And really what this comes down to is manipulation of the conversions within a formula. So by taking a pounds per square yard and looking at your total distance, you can look at different types of formulas to determine what your yield has been. So that's what I say, in pounds per square yard, you can convert that to pounds per linear foot, tons per linear foot, linear feet per load. And basically with this, you need to know what is the area that you're paving, what's the depth, was your lay rate adjusted through any use of the MAF factors, and at the end of the day, what was the tonnage placed? Or within just the certain window that you're doing the measurement for. So another practice problem. For this one, we're going to determine the adjusted lay rate from the MAF. That's the first step for this. So, you have a category 4 intermediate mix. The design lay rate's given to you of 275 pounds per square yard. You have a given planned quantity, and your MAF is 1.015, so likely a mix with some steel slag in it. Going to take to determine your adjusted lay rate, you are going to take your design lay rate, multiply that by your MAF, and you get 279.1 pounds per square yard. Okay, so to continue this problem using the information that was given to you previously, this gives you some stationing and also tells you like your lane width, how many lanes, and it tells you your total weight tickets for that day of 3,047 tons. So we're going to do that conversion, that manipulation of the formula to figure out the unknowns that we are trying to look for. So the first step to this is to determine your average yield for the day. You first got to figure out what's the total linear foot that you paved. You calculate that using the stationing. You did 2 lanes, both 12 foot wide. You convert that by dividing by 9 from square feet to square yards. So you end up with just slightly over 21,000 square yards. And then from there, you multiply it by the tonnage that's converted to pounds to get your total yield in pounds per square yard. So that's how you get 282.3 pounds per square yard. So because it was given to you that your target was 279.1 pounds per square yard, and you had your actual or your average yield for the day was 282.3 pounds, you can compare the two, and that you can see that you had an over yield of about 1%. So you laid slightly more mix than what you're being paid for, right? So I don't know, you guys do this every day. I'm not in the field anymore. So my question for you is 1%, that's probably pretty close, right? That's a fairly good yield, not something to be concerned about. So your adjusted pay quantity for the day looks like you end up being paid about 40 tons less than what you actually laid. You take the 3047 divided by 1.015, you end up with 3,001.97 tons. Any questions on that problem? This was a heavy mix, right? Steel slag in it. I think this is our last practice problem to walk through. So your planned lay rate is 330 pounds per square yard. You get 5 loads throughout the day, 240,000 pounds. This tells you what your stationing was, 12 feet wide. And we're going to do what we did in the last problem. We're going to determine our yield, see if it was on target, overrun, or underrun. So first step is to figure out the length you paved, and then convert that to an area, knowing that it's 1 lane, 12 foot wide, and then change that to square yards. So you get 767 square yards. Your yield was your 240,000 pounds divided by 767 square yards, which is 313 pounds per square yard. It had told you in the problem that your adjusted plan lay rate was 330 pounds. So you have a slight underrun. Your pavement was too thin in this scenario. All right, using some of the same information that was given to you before, you are now going to look at your pounds per linear foot. So it gave you the area. When you take 12 foot times 1 foot, and then divide by 9 to get your square yards, you end up with 1.33 square yards per foot. Your adjusted plan lay rate is pretty straightforward. Use the 1.33 that you calculated right above. Multiply that by your 330, which was your adjusted lay rate. You get 440 pounds per linear foot. So if you ended up, when you actually paved it, that you put down 240,000 pounds and they were laid in a 575 foot long run, how does that compare with what was planned? Well, you're going to take 240 divided by what that 575 was, and you get 417.4 pounds. Same calculation as what we had done before. You're just looking at it at pounds per linear foot, and it's just the same way of looking at yield. So you also see that this was an underrun. And then the very last way, last equation to understand is looking at it as tons per linear foot. So in this case, they give you the adjusted lay rate, the paving width. By taking your adjusted lay rate and looking at 330 times 12 and then dividing that by 2,000, which is the number of pounds, times 9 to get it into linear foot instead of square feet. That's where you get 0.22. And that's what your tonnage is that you laid per linear foot. Are there any questions on any of those 3 calculations? All right, so then they just had a note here that an easy conversion to remember is that 110 pounds per square yard per inch is equal to 0.055 tons per square yard per inch. And again, remember that's for a limestone mix with an MAF around 1. This is the linear foot per load. This might be the easiest one of all because you know that a load is 20 tons at 2,000 pounds per ton. That's 40,000 pounds total. You know that an area that load covers, based on the givens from the previous couple of pages, is the 40,000 pounds divided by your 330 pounds per square yard. And you get that the total coverage of those 20 of the loads that was given for this project to be 121 square yards. The area in square feet is 121.2 times 9 to basically manipulate that from square yards to square feet. You get 10,909. And knowing that the length covered by that is a 12-foot wide lane, you can see that it's 90.9 linear foot. So this tells you 1 truckload of material that's 12 foot wide, and in this case, 330 pounds per square yard is, when it's all said and done, going to cover right under 91 feet. There we go. And that's it. Hopefully that all made sense. I know it was just a lot of numbers, a lot of calculations real quick, but I think really the the takeaway that I wanted you to have from hearing this presentation is just understanding what an MAF factor is, understanding when it comes into play when you're in a plant and you're figuring out tonnage, and then also knowing why INDOT adjusts your pay quantity because of the fact that you're paid on tonnage and yet the design is based on the length of the road. That's all I have. So I think, Rob, are you ready? You're up.